So how are we going to set something up for this one?
Set up the equation.
More specific. Where are we going to start with?
Our base.
We can start with whichever one we want. We normally have our A, our B, and our X. So what pieces do we know? We start with 2 snakes. Which piece is that? A. What else do we know? Triples. What does the triples tell us? How do I triple something? I had like a triple stuffed Oreo, like. I know, it's okay. It's early, and about half of us staring at our cell phones, which surprisingly don't have the answers to the questions I'm asking out loud. Oh snap! What? You know who's not on TikTok right now? Me! Or on Insta, or whatever you're on. What does triples mean? What do you say? Y'all gonna make her answer all the questions? Come on. Y'all know what triples means? Yes, 3 times by 3. Triples times by 3, which tells us our base is what? 3. It's gonna triple. That's not a pen. It's gonna triple. It's gonna times by 3. So we can write our equation here as our 2 times 3 to our x, whatever our x is. That can be our equation. Now see if you can figure out our values for these 2 questions, 3 years and 10 years. Take like 30 seconds to do that. Which one are you going to say? Oh, the quiz. Okay, cool. Have you started or starting now? Okay, just double check it before I pull from a different spot. Yes, there's a second folder up from the bottom. So what do we think for 3 years? How many snakes will the zoo have? Because we're taking this 3. I say, y'all, we're going to keep using this today. It's going to be, kind of important for this chapter because it's the structure. They're only going to get more complicated than this. This is about as simple as they get. So when we type that in, you can type that into the calculator. 2 times 3 to the 3rd. How many snakes are they going to have in 3 years? 54 snakes. Sneaky snake. How about in 10 years? Are they going to have an absolutely illogical number of snakes?
It's not really logical.
It's not very logical. Because they're going to have how many snakes in 10 years if they do not change something in their breeding program?
118,098.
And 98. Yeah, they're going to have almost, they're going to have almost 1,200,000 snakes. So we would get 118,098 snakes. That is a lot of snakes.
I mean, if it's an endangered snake, I would understand.
Yes, but they also still need to fix their breeding program and probably have significantly larger buildings for that many snakes.
Yes. We'll start with this.
Oh, that would, yeah. So, I'm gonna see. They're gonna have to make some changes to their program.
I mean, that's
Right. But, you know, that's the vibe we're working with right here. So the bottom one is kind of a chaotic question. It's not like a thing relevant to what we're doing. It's just kind of a pattern recognition, but they'll put these on things like SAT. So look at this series of numbers. What would be the next piece? Trying to see the pattern in it. I'm gonna zoom it in just so we can see it because I know it's really close to the bottom. See if we can see what's happening between these numbers so that we can find our next one. Why? Yeah. These are all multiplying by 2. It's doubling. Doubling 2 gets 4. Doubling 4 gets 8. Doubling 8 gets 16. Doubling 16 gets 32. So doubling 32 gives us 64. They're all times 2. So if they give you a list of numbers, see if you can figure out what's happening there. They love to do that kind of pattern recognition. So, questions on homework? Because we're going to look at things like this. This is what our whole chapter's about. It's just going to kick up a little mess today. Because today we're not going to deal with things that are doubling or tripling, where it's like really easy, simple multiplication like that. Things are going to get a little bit more complicated today.
Of course they are.
Of course they are. We're only on day 2. So, this is what we did yesterday. That's called like a scaling multiplication. So things like double, triple, quadruple, halve. Those things are all things that work on this kind of structure. Sometimes we're going to have things that grow or decay at a percent rate. In which case, what we need to do is this base is a little bit different because instead of it just being times 2, times 3, we need to take 1 plus or minus, depending on whether it is growth or decay, whether it's getting bigger or getting smaller, and our rate, the percent that's written as decimal. So a really important piece here, how do I take something that's a percent, like, oh, say 25%, and write that as a decimal? This is, Because what we do is we take our decimal place and we go 2 spaces over. So 20.25 is our decimal. What if it was something like 3%? What is that as a decimal? We do the same thing. We go over 2. So my decimal point's here, but I need a space holder here. So 0.03 is the decimal version of it. This is super important for this. If we don't do this right, it is impossible to get our answers right. So make sure you're paying attention to this. You're going to want to write this form down. Our A is still the same thing it was on the last one, where it's our starting amount. Our base is still how it's changing, but the base is now this 1 plus or minus r. And our x is still the exponent. So this time it's just going to have that it's growing at some percent instead of saying double, triple, whatever keyword. Okay? So we're going to look at the one problem we didn't do on the little notes paper from yesterday first. That's fine. You also don't have to write every word, but I like go for it. It's like we're fine. We will be okay on time today. Yes, pre-cal. Okay, so you want to get this form down because this is the one we're using today a lot. Just trying to think. I think Monday will not be a new form technically, but I think Wednesday we'd get another form. We'll get more than this. Like there's a lot of forms.
Ew.
We'll give you them on the test, but you just got to know how to use them because they're not labeled.
Ow.
All right, So we'll get problems like this, not multiplying by a whole number. So it's not doubling, it's not tripling. This one is that our population of Albany, Kentucky is growing at a rate of 2% annually. Annually just means each year. And that the current population is 25,000. So we're thinking about that form we just wrote down. So our A times 1 plus or minus R to the X. So are we going to be using a plus or a minus on this one? What do you think? Plus. Why do we think plus?
It's growing.
Because it's growing. That tells us we're going to use the plus. It's getting bigger. So what is our A going to be? What's our starting amount? Yep, the 25,000. It's all good. I know what you meant. What's our R going to be? 2%, but we need to write it as 0.02. This is my R. You have to have it as a decimal. Have to, not optional. It does, like, it would be points off, not me being petty or mean. It's wrong. So filling in our equation here, we've got our 25,000 times 1 plus our R, which is that 0.02 to the power of X. And that is okay for an equation. I would like us to do the first set of simplifying we can do on these ones. So I want us to simplify inside our parentheses. Whenever we have a equation that looks like this, I want us to simplify inside the parentheses before we really count it as like being done with the equation. So we need to simplify this piece. Because our 1 plus 0.02, what is 1 plus 0.02?
$1.02.
1.02. So we have our 25,000 times our 1.02 to the X. So this is our equation. So how can we tell how many people are going to live in Albany in 20 years? What can I do with that? I don't have to write things out in like a table or anything. What can I do with that 20 years?
Would that be the X?
That's going to be our X. Our X is going to be the unit of time. Every single time. Some people write these equations with a T in that spot. I just feel like we're more comfortable with X. So the 20 is going to go in as our X. So we can take this and put our 25,000 times our 1.02 to the 20.
Big number.
Yeah, well, it's growing, and it's a big group of people to begin with. It's our 25,000 people.
Plus a lot of decimals.
Mm-hmm. So we get what? Like straight out of the calculator, what do we get?
3,300.
You can just say numbers. 37148. Yep, 37148. When in doubt, go backwards and do a comma there. 0.6849.
You can round it up to 7.7 though, can't you?
Oh, see, that's my question. What are we talking about here again in our story? What are these that we're counting?
Humans.
Human beings. How many people's that?
Like one, it's basically 0.5 at this point. There's no,
Can we have 0.5 of a human?
not unless there's only
That's. If you tell me you got a 0.5 of a person, you have tossed a leg into town. If I lob a random leg into the center of town, it's probably going to affect my population. Do not toss random limbs into town. Do not tell me we have part of a person. Yes, that's what's come out of the calculator. if it's a living creature. Whole numbers only for final answers. No partial people, no partial elephants, not even partial fruit flies. Whole numbers. Do not toss random limbs into town. It will affect your population. So our final answer on this, we're going to have our 37,149 people. So we will get decimally answers, but we do have to logic our way into it and figure out where we're rounding. If it's people or anything alive, whole numbers only. We're going to keep the damage to the population minimal. I was like, because we do things sometimes with like endangered animal problems, like the snakes at the beginning. Like we're not tossing a random half a snake into the den. No.
I mean, you could technically do that with starfish because they regrow their limbs, but that would still be bad.
I think even then it still counts as an entire living creature.
Yeah.
Just because I'll always have someone that'll argue me, like, what about an amputee? I'm like, they're not a half a person. They're still a whole person, even if they're missing a limb. The only way you can get a part of a person is if I toss literally like a leg or an arm. That's a part of a person. Anything that involves like the thinking and growing parts, that's where the person lives. So children still count as whole people too, because that's the other argument I get. People, animals, anything alive, no decimals. Money, 2 decimals. Those are about the only kind of situations we're going to see. Okay? We have theoreticals, which will get gross decimals. Living creatures, which will round off to the nearest whole number. Money will get 2 decimal places. So let's try another one, something kind of like this, where we're working with our percent rates here. So this is how things in the real life really work. This is true, brand new car for $23,000. So that's not even like a fancy schmancy car. That's like a Toyota Camry. $23,000.
Oh my god, my mom used to have a Toyota Camry.
It's like, it's not a bougie car. It's a good car. It's a fine car. It's a reliable car. But it's not like we're not BMW life over here.
Yeah, someone ran into the back driver's side backseat door right over there at the freshman center.
Oh, fun. So we've got this brand new car that's costing the $23,000. So we're brand new in it. And its value depreciates 15% each year, which is honestly right about average for car depreciation. Does depreciate mean get bigger or get smaller? Smaller. This is not going to be growth. This is going to be decay. Depreciates means get smaller. It loses values. So when we're looking at our equation, we're going to use the minus. So if we think about our kind of basic structure that we have, our a1 plus or minus r to the x, we are going to use the minus on this one. What is our a going to be? The money, that $23,000. It's what we're starting with, the initial value, our starting amount. What is our R going to be? In purple. Yes, because we need to take our 15% and scooch our decimal twice. So our rate is going to be 0.15. If you do not make this switch, it will be wrong. You have to. Have to. So when we're writing our equation for this situation, I have all the pieces right here. We've got our $23,000. Our formula, we have our 1 minus our 0.15 to the x. And I do want us to simplify here. We're going to simplify inside the parentheses. This guy. So our 23,000 isn't changing. What do we have inside our parentheses when we simplify our 1 minus 0.15? 0.85. So we can really see here, when we look at this compared with our, like yesterday formula, our base is 0.85, meaning it is smaller than 1, therefore it is decay. On our last one when we simplified, we had 0.12, which is bigger than 1. Barely, but it's bigger than 1. So this is how we can see this one was growth. Our base is still doing that. Bigger than 1 makes it grow and get bigger. Smaller than 1 is going to make it shrink and get smaller. This is going to decay. So if we do have this car that depreciates 15% a year, after 5 years, how much is this car worth?
10,205.
Whoo, that's a lot of value to lose.
42.
Mm-hmm. I'm just putting it in because otherwise my brain does not process the numbers that quickly. So, and I didn't do this on paper before. So we get 10205.22219. Where we round this off? 2 decimal places, because this is all money. So if I want to round it at 2 decimal places here, we're going to have our $10,000, or $10,205, and how many cents? If we're rounding it right there. 22 cents. So this is my little lesson on don't buy brand new cars, because this is about average on depreciation. Cars do not count as investments in terms of the growing your funding. They are a tool that you need. Yes, get one that makes you happy if you've got the money to afford to do so. But it is not a way to make money. There are very few cars that do not depreciate like this. And usually those are way too expensive anyway. Okay, so these are the kinds of equations we're going to work with. They're very, very much based on what we did yesterday. Okay, so I know yesterday I talked like right up to the end because we had a billion and a half things to talk through. So what we're gonna have now is actually time when you can try things, work, do the homework. I gave it to you yesterday. Huh? Yeah, I can get it for you, and so we can get started. Okay, so homework 7.4 is gonna be due on 7.1. I'm good at reading things. Is gonna be due on Tuesday, because we are going to finish up with the solving stuff that's on the back that has like the numbers to exponents. Like it's not stories, it's just like numbers. We're going to do that on Monday. So homework 7.1 is going to be due on Tuesday. SATs are happening next Thursday, so just letting you know in advance. And our chapter test is going to be on the 14th. Okay?
Don't forget we turn in our homework.
Yes, thank you. I will write that in here. So make sure you turn in your bell work. If you have anything that you got that's past due, get that turned in. I'm going to do my best to get everything caught upgraded over this weekend. But, you know, we'll see how it goes. So turn in bell work.
Why is this week your favorite challenge problem?
Because it's my favorite challenge problem.
It's not really.
Well, then try it. I know, I'm horribly cruel. Let's throw that last box on the bell work page. It's been there since August.
I love how the chapter test is on Pi Day.
It is indeed on Pi Day. I'm not bringing you pie. Preeminent. Okay, so work on stuff. If you ask questions, do the things. You can do everything on the front of homework 1 and the first 2 on the back. The only thing you can't do is question number 7. Question number 7 is what we're going to talk about on Monday. Okay, so you guys can do everything on the front and the top half of the back. So use this time to work on it so that come Monday, all you have is these 4. So work on stuff, ask questions, do the thing.